Welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl. The dog days of August are here, and if you're in the Northeast U.S. like I am, you've likely been dealing with plenty of hot, humid weather. Fortunately, the skies have been pretty cooperative, so I hope you were able to enjoy some of July's celestial highlights. This month, we'll check out the planets and when to best spot them, get a quick astronomy news update, and explore a fun and unique valley on the moon before exploring some of the best deep sky objects that Scorpius has to offer. Okay, we have a lot to explore this month, so let's dive right in. We'll kick things off with our tour of the planets for August 2025, and there's a lot to keep an eye on this month. Mercury starts off August as a morning object, visible low in the eastern sky just before sunrise. It'll be visible all month long, but your best views will be from about mid-month through the 28th, when it climbs higher each morning and brightens. On the morning of the 15th, Mercury will be glowing at magnitude 0.6, and will show a disk that appears about 8 arcseconds wide. By the end of August, the innermost planet will have brightened to magnitude minus 1.27, and will have shrunk to about 5.5 arcseconds wide. On the morning of the 19th, Mercury will pass about 2 degrees south of M44, the Beehive cluster. If you're out around 5:30 a.m., look toward the east-northeast. Seeing Mercury paired with that iconic star cluster will make for a beautiful binocular sight, although it will be low and the sky will have begun to brighten with twilight. Venus continues to shine brilliantly in the pre-dawn sky. Even though it's sinking lower each morning, it's still unmistakable and far brighter than anything else in that part of the sky. As August begins, Venus rises at 2:58 a.m. and is glowing brightly at magnitude minus 3.6, while in a telescope, the planet shows a 75% illuminated gibbous phase that spans about 14 arcseconds across. By the end of the month, Venus rises at 3:46 a.m. and has brightened to magnitude minus 3.9, while showing an 84% gibbous phase that spans a little more than 12 arcseconds wide. On the morning of the 20th, Venus will sit just 4 degrees south of the waning crescent moon. Jupiter will be nearby as well, forming a lovely triangle in the early morning sky. Then, on August 31st, Venus will pass just 1 degree southwest of M44, making for another great opportunity for early risers with binoculars or a low-power telescope to catch this stunning pair. Will bright Venus make the Beehive harder to see? Let us know. Mars, on the other hand, is quickly fading from view. It's a faint reddish dot in the western sky after sunset, and it's getting lower and dimmer each evening. It begins the month at magnitude 1.56, and by the end of August, it will have dimmed slightly to magnitude 1.62, while showing a disk about 4 arcseconds wide. It's starting to get tough to pick it out of the twilight glow, but you'll have some help on the evening of August 26th. Look for Mars about 5 degrees west-southwest of the thin waxing crescent moon. It'll be low on the horizon, so try to find a spot with a clear western view just after sunset. Mars will continue to become more difficult to see, and will get lost in the glare of the sun this fall. Jupiter is becoming more prominent again in the morning sky. Early risers will find it climbing higher before dawn as the month goes on. One of the most striking planetary conjunctions of the year takes place on the morning of August 12th, when Venus and Jupiter appear just 51 arc-minutes apart. That's less than the width of 2 full moons. The pair will look fantastic to the naked eye, and through binoculars or a telescope, they'll be a real showstopper. Then, on the 20th, the waxing crescent moon, Venus and Jupiter all come together in the morning sky, forming a beautiful triangle in the pre-dawn skies. This is going to be stunning in binoculars or with the naked eye. Wide-field astrophotographers are going to have fun with this grouping. Saturn rises before 10:30 p.m. early in the month, and a bit earlier each night as it approaches opposition next month. On the 1st, the ring planet is in Pisces, glowing at magnitude 0.8. In binoculars, you might be able to see the rings, which are almost edge-on right now, but through a telescope, they become easy to spot. By month's end, Saturn rises at 8:24 p.m. and has brightened slightly to magnitude 0.65. In September, Saturn will be at its best when it reaches opposition, but now is still a great time to observe it. On the night of August 12th into the morning of the 13th, The waning gibbous moon, at 89% illumination, will be just 3.75 degrees east-southeast of Saturn. If you're observing late that night, this pairing will make for a great target with the naked eye or binoculars. Uranus is visible all month long in the morning sky, sitting about 4 degrees south of the Pleiades. On the 16th, it'll be about 7 degrees southeast of the first quarter moon. Although faint at magnitude 5.8 and spanning less than 4 arc seconds, Uranus is easily within reach of binoculars or even the naked eye from a dark site. And the planet is easy to spot with a small telescope, even from suburban skies, although it will only appear as a bloated star. Neptune, meanwhile, spends the month close to Saturn in the night sky, although you'll need at least a 3-inch telescope to spot its tiny blue disk. All month long, this distant planet glows dimly at magnitude 7.7 and spans just over 2 arcseconds across. It doesn't change positions dramatically in the sky this month, but if you're already observing Saturn, it's worth slowing a few degrees to the east and taking a look at Neptune as well. As this episode is being recorded, there are no comets brighter than 13th magnitude that are currently visible. The Perseid meteor shower peaks on the night of August 12th into the 13th. This reliable shower can produce up to 100 meteors per hour, but unfortunately, this year the nearly full moon will wash out all but the brightest of the Perseids. It's just not a great year for this shower. I want to welcome you to a newish segment. We're renaming our monthly space mission update to a segment that I'm calling Astronomy News. Who knows, maybe I'll even come up with a stinger for it. We'll still give a space mission update about interesting missions, but we'll use this space to also report on comets and other transient events, along with important discoveries that are being made. There are lots of planned launches, most of which are unmanned this month. However, scheduled to launch on July 31st aboard a Falcon 9 powered Crew Dragon will be 4 astronauts, 2 Americans, 1 Japanese, and 1 Russian. They will serve on Expeditions 73 and 74 at the International Space Station. The Axiom 4 mission, which launched 4 private astronauts to the ISS on June 25th, successfully completed its mission when it splashed down in the Pacific Ocean on July 15th. Hats off to everyone involved in this historic mission. And on July 14th, a Type 1a supernova was discovered in the galaxy NGC 7331 in Pegasus. As I write this, supernova SN 2025 RBS, its catalog number, is glowing at 14th magnitude and is expected to reach around 9th or 10th magnitude by the end of July. It will then fade over several weeks, but for now, it makes the brightest member of the Deerlich group of galaxies even more enjoyable to explore. And last but definitely not least is an important update about the Vera C. Rubin Observatory. There's a brand new way to explore our solar system, and it's incredibly cool. The Vera C. Rubin Observatory just unveiled Orbit Viewer, a web-based app that lets you dive into the 3D motion of thousands, even millions of objects in the solar system, all in real time. Powered by real data from Rubin and analyzed by the Minor Planets Center, this isn't just eye candy. It's a powerful scientific tool that's also intuitive and fun to use. Orbit Viewer works right in your web browser. No downloads or installations required. Whether you're using a phone, tablet, or desktop, you can rotate the solar system, zoom in on specific objects, filter for categories like asteroids, comets, or trans-Neptunian objects, and even scroll through time from 1900 to the year 2100. You can explore 4 viewing modes, ranging from 16,000 to over 1 million objects, depending on how powerful your device is. And with Rubin set to discover more solar system objects in its first year than we found in the last 150 years, that discovery counter is going to climb fast. This is the kind of tool that makes the invisible visible, bringing orbits, motion, and solar system structure into view. It's a great tool for educators, students, astronomers, or anyone who wants to get a better feel for the dynamics of our solar system. Just head to the Rubin Observatory website and give Orbit Viewer a spin. You're going to love it. The link is in the show notes, as is a link to our All About the Vera Rubin Observatory episode. Now it's time for the Lunar Feature of the Month. If you've ever spent time exploring the moon around the waxing gibbous phase, you may have noticed a winding, snake-like feature just north of the large bright crater Aristarchus. This is Schröter's Valley, also known by its Latin name, Valles Schröteri. It's the largest sinuous rille on the moon, and one of the most fascinating volcanic features you can see with amateur equipment. Schröter's Valley begins northwest of the brilliant crater Aristarchus, near a small volcanic crater known as the Cobra Head, a curious name that comes from its rounded shape and the way the valley appears to spill out of it. From there, the valley winds its way northward and then curls back toward the south, spanning an impressive 160 kilometers. It's about 100 miles long. It ranges from about 6 to 10 kilometers wide and reaches depths of up to 1,000 meters or 3,300 feet. That's nearly as deep as the Grand Canyon. What makes Schröter's Valley so striking isn't just its size, it's the way it twists and turns like a meandering river. But unlike rivers on Earth, this wasn't carved by water. Schröter's Valley is believed to be an ancient lava channel created billions of years ago during a time when the moon was still volcanically active. As molten lava flowed across the lunar surface, it likely eroded a path through the surrounding terrain, leaving behind this rille. And here's where it gets even more interesting. In high-resolution images, a narrower rille runs right down the middle of the wider valley, almost like a river within a river. This narrower channel may have formed later, when a smaller stream of lava cut through the center of the original flow path. These features suggest complex, long-duration volcanic activity, something we're still trying to fully understand. So who was Schröter? The valley is named after Johann Hieronymus Schröter, an 18th century German astronomer known for his detailed lunar sketches and studies of planetary features. His work on the moon and planets laid important groundwork for observational astronomy centuries before photography was widely available. Naming this dramatic valley after him is a fitting tribute to someone who spent countless hours mapping the lunar surface with a telescope. The best time to observe Schröter's Valley is 2 or 3 days before full moon, when the sun is low on the lunar western horizon. The low angle of light casts long shadows across the valley, accentuating its depth and curvature. Under those conditions, even modest backyard telescopes can bring out the valley's winding shape. To find it, first locate the bright crater Aristarchus, near the moon's western limb. It's one of the most reflective spots on the moon, and it really stands out. Just northwest of it, near the Aristarchus Plateau, you'll see the valley snaking away towards the north. A 4 to 6 inch telescope at around 100 power will show it nicely, and under steady seeing conditions, bumping up the power can reveal even more details. So the next time you're observing the waxing gibbous moon, take a few minutes to track down Schröter's Valley. It's not just one of the moon's most striking volcanic features, it's a glimpse into a time when the moon was alive with fire, not just rock and ice. This month, our Deep Sky Tour takes us through one of the most iconic and visually rich constellations in the summer sky, Scorpio the Scorpion. Easily recognizable from mid-northern latitudes as a giant fishhook or J shape curling up from the southern horizon, Scorpio isn't just fun to look at, it's absolutely packed with lots of great deep sky treasures. It lies along the densest part of the Milky Way, and that means lots of open clusters, globular clusters, and nebulae, all nestled into one area of the sky. Let's begin our tour with the bright red star Alpha Scorpii, which is commonly known as Antares. Its name means the rival of Mars, and it can be confused for the red planet, which can appear similar. This reddish-orange supergiant glows at magnitude 1.0 and marks the heart of the Scorpion. It's a spectral type M star, located about 550 light-years from Earth, and has a diameter roughly 700 times that of our Sun. It's also part of a multiple star system with a magnitude 5.16 blue companion that's tough to see visually, but can sometimes be glimpsed in larger telescopes under good seeing conditions. The pair are separated by less than 3 arcseconds. If you're not looking for the companion, try defocusing Antares a bit to see the reddish-orange color of the star. It's a great way to start a night of observing. Our first deep sky object on our tour is Messier 7, also known as Ptolemy's cluster. The cluster was likely first recorded by the ancient Greek astronomer Claudius Ptolemy around 130 AD. In his great astronomical treatise, the Almagest, Ptolemy described a nebula following the sting of the Scorpius, a description that matches the position and appearance of M7 in the sky. Of course, in Ptolemy's time, telescopes didn't exist, so clusters like this one were recorded as fuzzy or nebulous patches to the naked eye. It wasn't until much later in the 17th and 18th centuries that astronomers with telescopes could resolve M7 into individual stars. In 1764, Charles Messier officially cataloged it as the 7th object in his list of nebulous objects, not to be confused with comets. This beautiful open cluster lies near the stinger of the Scorpion's tail and is one of the brightest and largest open clusters in the sky. It glows brightly at magnitude 3.3 and spans about 80 arc-minutes wide, while containing around 80 member stars. It is located about 980 light-years away from us. From a dark sky sight, the cluster is an easy naked-eye object as a large, hazy patch of light. If you're really trying, you can even begin to resolve some of the cluster's brightest stars visually. With binoculars, the cluster's brightest stars will easily begin to resolve. In my 70mm refractor, the cluster looks large and bright, with more than a dozen stars becoming visible. In my 8-inch Dobsonian, the cluster is really stunning, revealing even more stars among a rich star field. To locate M7, start at magnitude 1.6 Shaula, also known as Lambda Scorpii. From there, sweep 4 degrees east and just over 2 degrees north, and you'll spot M7. Just a little less than 4 degrees to the northwest of M7 is the beautiful open cluster Messier 6, which is often called the butterfly cluster. This moniker was given to M6 by Robert Burnham, who described it thusly: a charming group whose arrangement suggests the outline of a butterfly with open wings. This open cluster lies a bit higher in the sky than M7, and it is just as eye-catching. Spanning about 25 arc-minutes in diameter and glowing at magnitude 4.2, the cluster is comprised of around 80 stars and is located about 1,600 light-years away from us. Under a dark sky, it's visible to the naked eye as a soft, fuzzy patch of light, a bit smaller than the moon. In my 70mm refractor, it displays a sparkling of blue and white stars, with a 6th magnitude orange star standing out on the eastern edge of the cluster. In my 8-inch Dob, dozens of stars are visible, and the cluster stands out well from the rich background. It's a fantastic binocular object and great in wide-field telescopes. I'm sure that you'll observe it over and over again. Moving a bit further south and west, we come to our next object, NGC 6231. This young, compact open cluster lies near the head of the Scorpion and is sometimes called the Northern Jewel Box because of its resemblance to the famous Southern Hemisphere cluster. It's home to several hot, massive stars and lies embedded in a rich star field, making it a standout visual target. Made up of about 120 stars, the cluster is bright at magnitude 2.6 and spans 15 arc-minutes wide. The cluster is located approximately 5,900 light-years away from us and spans about 25 light-years across. To the naked eye, the cluster appears as a mottled patch of light, about half the size of the moon. Through binoculars, you can reveal several member stars in the cluster. In my 70mm refractor, the cluster resolves into about 40 stars packed into a tight group, and it really pops against the background stars. In my 8-inch, the cluster is really beautiful, and it holds up well at higher magnifications. Finding NGC 6231 is easy. Start at magnitude 3.6 Zeta Scorpii and sweep half a degree north, and you'll spot the cluster. Unlike me, you actually might get tired of looking at open clusters. So, our next object takes us on a bit of a different course. Let's explore the globular cluster M80. This is a small but bright globular cluster situated about halfway between Antares and Beta Scorpii. It's one of the most densely packed globular clusters in the sky, with hundreds of thousands of stars crammed into a tight core only about 10 arc-minutes across. The cluster glows at magnitude 7.3 and is about 32,600 light-years away from us. In binoculars, it appears as a small, unresolved glow, while in my 70mm refractor, it looks like a compact fuzzball. With my 8-inch SCT at higher magnification, you can start to resolve the outer halo of the cluster, offering a beautiful view. M80 is often overlooked because of its proximity to other splashier objects, but it's well worth a visit. To locate M80, imagine a line from Antares to magnitude 2.6 Acrab. You can find M80 at about the midpoint of that line. If our next object were located further north in the sky, it would be on just about everyone's list of favorite globular clusters. Luckily for us, even though it doesn't climb very high from mid-northern latitudes, we still get a good view. Of course, I'm talking about M4, an outstanding globular cluster that lies just over 1 degree west of Antares, making it incredibly easy to locate. M4 is a classic. At a distance of just 7,200 light-years, it's one of the closest globular clusters to Earth. That proximity makes a big difference. It appears large and relatively easy to resolve, even in smaller telescopes. Shining at magnitude 5.4 and spanning about 26 arc-minutes across, M4 is nearly the same apparent size as the full moon. From my home in New Jersey, M4 appears in binoculars as a soft mottled glow next to Antares. But when I observe it from a dark site in Vermont, that same view through binoculars shows resolution where the individual stars in the cluster begin to pop out. And through any decent telescope, especially under dark skies, you'll see dozens of stars resolve across the cluster. In my 8-inch Dobsonian, M4 is a true showpiece. The outer halo of the cluster sparkles with pinpoint stars, and the core displays a fascinating bar-like structure, a chain of bright stars running through the center. It's a unique feature that really stands out. M4 should absolutely be on your list of must-see summer objects. It's bright, easy to find, and one of those targets that never disappoints. Our next stop is Messier 62, and while it doesn't get a lot of attention, mostly due to its far southern location, it's absolutely worth tracking down. M62 is a bright, compact globular cluster tucked away in the body of Scorpio. If it were positioned just a bit farther north, it too would be on a lot more observers' lists of favorite objects. Shining at magnitude 6.5 and spanning about 14 arc-minutes across, it's easily visible in binoculars from a dark site, though it doesn't climb very high in the sky for mid-northern observers. Through my 8-inch Dob from a dark location, M62 reveals a bright, dense core and a slightly irregular halo that's rich with stars. One thing you'll notice is that the cluster's core is slightly offset a bit to one side. It's not perfectly symmetrical, and that off-center concentration gives it some visual character. With continued observation, especially under steady skies, you'll begin resolving stars well into the halo, and the cluster takes on a grainy, glittering texture that really comes alive. M62 might not have the fanfare of nearby M4, but don't let that fool you. This one's a stunner too, and a great reward for those willing to search the skies of the Scorpion. Finding M62 is pretty easy as well. Start at Antares and sweep 3.5 degrees south, and then sweep about 7 degrees west, and you'll spot the cluster. Now it's time for this month's Deep Sky Challenge object, and for this one, we're going to remain in Scorpio, not far from the brilliant red star Antares. Our target, the faint and often overlooked globular cluster, NGC 6144. NGC 6144 lies just 28 arc-minutes, a little less than half a degree northeast of Antares. And while that makes it easy to find on a star chart, actually seeing it can be a bit tricky. Why? Well, 2 reasons. First, it's pretty faint, glowing dimly at magnitude 9.6, and second, it lies right in the glow of Antares. That combination can make it a bit of a ghost to track down, especially from light-polluted skies. This cluster is about 33,000 light-years away and spans just under 9 arc-minutes across. That makes it pretty compact, but it's much less dense than brighter globulars like M4 or M80. In fact, NGC 6144 is classified as a low-concentration cluster, which means its stars are more loosely distributed and the core isn't as sharply defined. In binoculars, you probably won't see much of anything due to its faintness and the bright background around Antares, but with a 6-inch or larger scope in dark skies, you'll begin to pick up a soft, round glow. With my 8-inch SCT, I can just begin to resolve some stars around the edges, especially when I nudge Antares out of the field of view to cut down on the glare. Higher magnification and averted vision really help to bring it out. And if you're using a larger aperture telescope, say 10 inches or more, this one becomes much more satisfying. There's something really rewarding about observing these faint globulars. While they may not be showpieces like M4, they offer a quiet challenge. They make you work, and that makes finding and observing them all the more enjoyable. So give NGC 6144 a try this month. It's faint, but it's right there, hiding in plain sight next to one of the brightest stars and globular clusters in the sky. If you're up for the challenge, I think you'll enjoy the hunt. Well, thanks so much for joining me. I hope this episode was fun, informative, and inspires you to get outside and look up. If you've got questions, feedback, or ideas for future episodes, shoot me an email at astroguypodcast@gmail.com or leave a text or a voicemail at 973-404-0380. Be sure to check out the AstroGuy Podcast group on Facebook. You can also visit our YouTube channel for past episodes, observing tips, and bonus content. If you found this episode helpful, please like, subscribe, comment, and share. It really helps us grow. Until next time, may your skies be clear, and as always, carpe noctem, seize the night. I'm Wayne Zool, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.